Welcome to ITEM WMS, streamlining your warehouse from receiving to shipping and inventory control. Let's start exploring. ITEM WMS stands out with 5 key features: refined management, high adaptability, visualization, real-time monitoring and alerts, and multi-dimensional product management. At its core, ITEM WMS is built around 5 major operational processes: order processing, receiving and put away, inventory management, allocation and picking, and packing and shipment. These are supported by a range of smart strategies including put-away rules, replenishment logic, picking and removal strategies, inventory turnover policies, and allocation rules. ITEM WMS also ensures seamless integration with external systems such as ERP, OMS, TMS, BMS, RMS, and YMS, enabling smooth data exchange across the supply chain. To date, ITEM WMS has been successfully deployed across a variety of industries, including but not limited to apparel, food and beverage, e-commerce and retail, electronics, automotive, forestry and timber, and third-party logistics, 3PL, proving its flexibility and scalability in diverse warehouse environments. This is an overview of our core system functions, which are divided into several major business modules, including foundation data management, inbound management, outbound management, inventory management, reporting, strategy management, PDA operations, and automation equipment management. Among them, the Automation Management module is part of the Warehouse Control System, UCS. Let's first take a look at our inbound management process, one of the core workflows in our WMS. Typically, customers or carriers schedule a delivery appointment via our client portal or through offline coordination with the warehouse. Carriers arrange for drivers to deliver goods at the designated time. Upon arrival at the facility, the driver checks in at the reception window. The system then recommends a suitable offloading dock and notifies the warehouse team in advance to prepare for offloading. Once the truck is parked at the assigned dock, the warehouse staff begins the offloading process, during which photos are taken to document the entire operation. After the goods are transferred to the staging zone, if the items arrive already palletized, operators will apply pre-printed pallet labels and complete the receiving task. If loose goods are delivered, the operator will palletize them according to the customer's specific requirements, apply the pallet label, and then complete the receiving task. During the receiving process, our system provides flexible options based on business needs, such as collecting batch numbers, serial numbers, manufacturing dates, shelf life, or expiration dates. Once receiving is completed, the system sends RC to the customer system and automatically generates put-away tasks. During put-away, based on product attributes and customer-specific rules, the system will recommend suitable locations according to configured put-away strategies, such as fixed location recommendation, same item location, same batch location, or same expiration date location. For shelving operations, we typically follow an upper storage, lower picking strategy to optimize accessibility and efficiency. Do you know how to complete the receiving and put-away tasks in the inbound process using ITEM WMS? Follow along with this video to learn how. First, log in to the WMS. Click on the facility name to view all facilities configured under your account. The WMS integrates multiple functional modules, such as transload, inventory, and more. To explore the inbound process, go to Warehouse Management WMS. For demonstration purposes, all operations shown in this video are manually created. Let's start by creating a new inbound order. Fill in the required basic order information. Then add items to the order and provide their quantity details. Once the inbound order is created, the carrier will deliver the goods to the warehouse at the agreed time. At this point, the security personnel at the gate will guide the driver into the warehouse after performing a window check-in. In the system, warehouse staff need to create an entry ticket under the window module. Select the task type and provide the carrier, vehicle, and driver information. Then, link the entry ticket to the corresponding receipt. Assign a warehouse receiver and allocate an available dock. Once the receive task is generated, the assigned warehouse staff can view task details and proceed via the WMS app. First, verify the dock information and complete the dock check-in by collecting relevant details. Next, select the equipment for offloading and upload relevant photos. Then, proceed with LP setup. Sort the goods onto pallets and print labels as needed. This completes the receiving task. You can go to the inventory module to check if the receiving goods have been successfully received in the stock. To continue, perform the put away task. Move goods from the staging area to the storage area. Note that the warehouse may have different zones for full pallets and loose pallets. Put away the goods and update the relevant data. Once all items are put away, the put away task is completed. Finally, return to the inventory module where you can search and verify the locations where the goods were stored. Now let's take a look at our outbound process, another core workflow in our WMS. Our system supports multiple order creation methods, including EDI, public APIs, FTP, manual input, and file imports. Once orders enter the WMS, users can manually or automatically perform pre-allocation, order planning, and picking task creation. If stock in the picking area is insufficient, the system generates replenishment tasks based on configured rules to ensure timely picking and avoid delays. We support various picking methods, including order-based picking, batch picking, and wave picking. During the picking process, the system calculates the optimal route and recommends picking locations based on preset strategies. In addition to manual picking, our WMS also supports multi-device collaboration, such as AGV-assisted goods-to-person picking, put wall picking, either pick and sort or pick then sort, air rob sorting, and pick-to-light guidance. Once picking is complete, small parcel orders are packed at packing stations and shipped after labeling. Our rate shopping feature integrates major U.S. carriers to help customers select the most cost-effective shipping option. For LTL or FTL shipments, the system generates loading tasks. Before loading, users can perform shipment verification and secondary bundling. The process is completed once the driver confirms, with the system recording photos, verification steps, shipping info, and signatures. After shipment, the WMS pushes the delivery confirmation to the customer system automatically. Join us as we walk through the outbound process by creating a shipment order. First, manually create an outbound order and fill in the necessary basic information, such as order type, retailer, reference number, and shipping address. Then, add the items to be shipped along with the relevant product details and quantities. Once the outbound order is created, the system will initiate order dispatch, including order quantity grouping and picking strategies. Start by accessing Inventory Commit. After a successful commit, go to Order Plan. Select the operators and the corresponding outbound orders. Next, create a pick strategy, generate pick tasks, and assign them to the appropriate warehouse staff. Identify available LPS license plates for the required items. Then, return to the WMS app and enter the ILP numbers to pick the correct quantities until the task is fully completed. Next, move the picked items to a staging location. Enter the location ID to complete the staging process. At this point, the picking task is completed. Return to the inventory module to check the inventory status of the picked items. You'll see the 4 LPs marked as picked, and each is linked to the outbound order. This indicates the goods are ready for loading and waiting for carrier pickup. Before pickup, warehouse staff need to create a load for the outbound order. Enter the load number, customer, carrier, outbound order, and other basic details. Then, gate personnel create an entry ticket for the driver to complete the pickup process. Select the task type and input carrier, vehicle, and driver information. Bind the load, assign a loading operator, and allocate an available dock to complete the check-in. At this point, the system automatically generates a load task for the assigned staff. Now, head over to the WMS app to complete the load task. Start executing the task. Scan or enter the pallet numbers for each item until all pallets have been successfully loaded. If the load task includes multiple orders, simply repeat the same steps to complete loading for each one. Next, enter the associated pro number, upload the photo of the outbound order, and click Complete Load to proceed. Fill in the seal number and upload the photos of the seal and the truck. Finally, have the carrier sign the shipping document. Once completed, the load task is marked as finished, and the associated orders and inventory will automatically update to shipped status. Finally, we come to in-warehouse management, which covers essential daily operations such as inventory count, adjustments, stock movement, inventory query, as well as pallet splitting and merging. Next, let's take a look at the overall system architecture. From top to bottom, the system is structured into 4 tiers: headquarters, branches, central warehouses, and regional warehouses. This hierarchical design enables enterprises to perform fine-grained, multi-warehouse operations across regions. On the right side, we see the warehouse spatial hierarchy, which consists of the following levels. Warehouse, divided based on physical locations, such as Valley View, Fontana, Alessandro, and so on. Zone, functional zones within a warehouse based on operational needs, such as frozen, refrigerated, temperature-controlled, and ambient areas, to meet specific product storage requirements. Area, subsections of zones defined by operation type, such as receiving, inspection, shipping, return, qualified goods, and non-conforming goods areas. This helps standardize space management across workflows. Location group, logical groupings of specific storage locations for special purposes. For example, separating dock-accessible locations from non-dock ones for better control. Location, the most fundamental unit in warehouse management, representing the exact physical position where goods are stored. This multi-level spatial management architecture empowers businesses with collaborative multi-warehouse operations, accurate inventory tracking, efficient task execution, and flexible space allocation. With this design, our WMS can support warehouse management needs across a wide range of industries, from single-site operations to large-scale multi-site networks, from simple to highly complex environments. Building on a multi-warehouse, multi-client architecture, our WMS enables refined, attribute-based product management, focusing on 6 core attributes. Strategy. Attributes define product-related rules and strategies such as shipping rules, serial number rules, and packaging rules, ensuring standardized handling across all operations. Packaging attributes support multi-level packaging definitions, including PL, pallet, CS, case, and EA, each, to meet diverse packaging requirements. Batch attributes allow flexible and dynamically extensible batch attributes, making it easy to track and manage a product's lifecycle. Shelf life control. Based on configurable ship-allow days and storage days, the system automatically flags expired items to prevent outbound shipment. Pallet specifications manage different pallet configurations for receiving, storage, and outbound processes, ensuring operational accuracy and flexibility. Product aliases enable the use of custom aliases for different retailers, customers, or suppliers, facilitating smoother collaboration across business partners. With these detailed attribute configurations combined with our robust multi-warehouse, multi-owner structure, the WMS ensures precise and full lifecycle management of every product in the system. Building on a robust warehouse architecture and comprehensive product attribute management, our WMS system offers flexible and diverse order intake methods. We support 4 primary order reception methods: External system integration. Through EDI, the system can automatically exchange order data with external platforms, ideal for integration with large-scale customer systems, ensuring both accuracy and real-time updates. OMS integration seamlessly connects with our order management system, OMS, to push orders directly into WMS, enabling full visibility and control throughout the order lifecycle. Bookkeeping system integration supports integration with financial systems, ensuring consistency between order data and accounting records. Manual input options. Manual entry. Users can create and manage orders directly within the system. Excel import supports batch import of orders using standardized Excel templates. This multi-channel order intake framework allows our WMS to adapt to various customer needs, improve order processing efficiency, reduce manual intervention, and lower the risk of errors, offering maximum flexibility and convenience for our users. Our ITEM WMS system offers 6 core strategies, enabling customized rule configurations for different clients and product types. Put-away strategy defines conditions for assigning storage locations during put-away, allows locating empty slots within specific zones, supports assigning the nearest available location for the same SKU, enables put-away into locations already storing the same product. Wave rule flexibly groups orders based on criteria such as consignee, carrier, or route. Supports automatic order merging to generate waves. Replenishment strategy customizes rules based on warehouse and operator needs. Supports setting minimum and maximum inventory levels. Allows prioritizing replenishment tasks. Turnover strategy controls the outbound sequence of goods. Supports FIFO, first in, first out, FIFO, first expired, first out, and other modes. Ensures proper inventory turnover. Allocation rule optimizes location allocation, improves picking efficiency, recommends optimal inventory positions, and handles exceptions intelligently. Route guidance generates optimal task routes based on location layout and operation type. Provides intelligent guidance for warehouse staff. Supports multiple scenarios like picking routes and replenishment routes. With these flexible strategy configurations, businesses can build a highly efficient, accurate, and controllable warehouse operation system. Now, we will introduce the intelligent functions of the ITEM WMS system in order processing, which mainly include 4 aspects: automatic order screening, wave rule configuration, execution strategy configuration, and picking strategy configuration. First is the automatic order screening function. The system can intelligently filter orders based on multi-dimensional conditions, such as order type, status, carrier, and item line. Through rule configuration, it achieves automated order processing, improving efficiency while reducing error rates. It supports dynamic adjustment of rules to ensure the system can adapt to evolving business needs. Second is the wave rule configuration. It allows setting personalized thresholds and grouping modes according to each customer's order characteristics. Supports multiple picking methods, such as single order picking, pick and sort, wave picking, etc. Continuously improves picking efficiency and accuracy through the flexible execution of pick tasks. Third is the execution strategy configuration. The system supports scheduled task setup to automatically filter and allocate inventory. It can be flexibly adjusted according to the enterprise's business processes and customer needs. Differentiated execution strategies are set for different order types to ensure priority processing of critical orders, effectively avoiding business delays caused by order backlogs or insufficient inventory. Finally, the picking strategy configuration has 3 core dimensions. Strategies based on shipping rules. Supports multiple outbound rules such as FIFO, first in, first out, and FIFO, first expiry, first out. Allows setting time windows to meet different timeliness requirements. Provides granular control over inventory expiration management. Strategies based on inventory structure. Optimizes configuration according to picking demands and inventory structure. Improves picking routes to enhance efficiency. ensures rational utilization of inventory. Picking task. Allocation supports task allocation based on operators' capabilities. The system automatically calculates the optimal picking route, ensures balanced task distribution to avoid overloading personnel. Through these intelligent configuration functions, our WMS system helps enterprises establish an efficient, accurate, and flexible warehousing operation system, significantly enhancing operational efficiency and customer satisfaction. Next, I'd like to highlight the innovative applications of our WMS system in multi-device collaborative operations. In modern warehouse management, a single operational mode can no longer meet increasingly complex business requirements. Therefore, we've developed a comprehensive multi-device collaborative operation solution. The core of this solution is the free combination of business needs and device scheduling. Our WMS system currently integrates and adapts to 5 advanced operational devices. AirRob system, an intelligent shuttle system designed for goods storage and retrieval in high-density storage areas, significantly enhancing access efficiency in automated warehouses. T-Sort sorting system utilizes yellow intelligent sorting robots to achieve efficient order sorting operations, ideal for e-commerce scenarios with high order concurrency. Pick wall system, equipped with intelligent LED displays and automated conveyors, supporting parallel picking of multiple orders to improve efficiency and accuracy. Pick to AGV system, deeply integrates AGVs with picking operations to enable human-machine collaborative intelligent picking, reducing operators' walking distances. Pick-to-tote cart system features a multi-level tote design, supporting batch and zone-based picking operations for flexible mobile picking solutions. These devices do not operate in isolation, but can be flexibly combined based on actual business needs. For example, combine AirRob with Pick Wall for intelligent material flow from high-density storage to picking areas. Pair Pick to AGV with T-Sort to create an efficient picking sorting production line. Select the most suitable device combination based on order characteristics. Through this flexible device collaboration mechanism, we can maximize device utilization, enhance operational efficiency, reduce operational costs, meet various complex warehousing scenarios. This is the innovation of our ITEM WMS in multi-device collaboration, providing customers with a smarter and more efficient warehousing solution. This is a more detailed explanation of the multi-collaborative operation system. An important innovation of WMS systems in the field of artificial intelligence is the introduction of AI agents. Today, we take the inventory commit agent as an example to demonstrate how AI helps improve warehouse management efficiency. Let's watch a video first.
The inventory commit agent is designed for inventory managers seeking to optimize their order processing efficiency. Handle exception orders through AI-driven conversations, enabling regular users to get started quickly. Initiate your journey by accessing the Inventory Commit Agent interface, the primary tool for streamlining inventory management. Engage with the system to start a dialogue, which is essential for obtaining real-time inventory updates. Use the query functions to gather comprehensive inventory data, which helps in making informed decisions. Agent assists you in reviewing inventory and order details, and helps release inventory and recommit through these 5 actions. At the end of the order information, prompt the user with the possible next steps they can take. Encourage users to provide the required fields for the next action. If the data you've already retrieved contains the fields needed for the next query, just need to input the corresponding order ID for the order you wish to query. Simply input your request, and the agent will intelligently understand what action you want to perform. This shows which order has occupied your inventory. Check the target completion date and priority points to confirm the order's priority and urgency. The end of the query result will display the next step you can take. Here, we decide to release this order. Here comes the last step. After release the occupied order, we need to recommit order we want. Input the command to commit. There is only one commit in all actions. So, there's no need to worry about the AI making mistakes. Revisit exception orders to monitor any changes, post-commitment, ensuring ongoing oversight. Conclude your session with a final review, reflecting on the efficiency gained through this feature. By utilizing the inventory commit agent, users will experience improved inventory management through real-time data access and streamlined workflows. This feature empowers users to handle orders efficiently, minimize exceptions, and maintain optimal stock levels, leading to enhanced operational productivity.
The Inventory Commit Agent is an intelligent assistant specially designed for inventory managers, featuring three main characteristics. First, intelligent decision-making capability, which can automatically analyze inventory status, make inventory allocation decisions based on multi-dimensional factors, and predict and proactively avoid potential inventory conflicts in advance. Second, natural language interaction, which adopts a conversational interface allowing inventory managers to ask questions in natural language, with the agent able to understand context and provide accurate responses. Third, efficiency enhancement, which significantly accelerates the processing of abnormal orders, reduces the error rate of manual decisions, and provides professional inventory optimization suggestions. Specific application scenarios include inventory allocation decisions during concurrent processing of multiple orders, priority handling in cases of inventory shortages, and more. This is just our first step in the AI field. In the future, we plan to launch more specialized AI agents, picking strategy agent, route optimization agent, and resource scheduling agent. Through the collaborative work of these AI agents, our WMS system will deliver a smarter and more efficient warehouse management experience for customers. This is our vision for future warehouse management: human-machine collaboration and intelligent symbiosis. Thank you for following along our other videos for more tips and guides. See you next time.